Hello everyone, in this video we're going to go over section 4.1 from your textbook, which is called Population, Sample, and Data. Chapter 4 is all about statistics. This is really just a very brief and a simple overview of some stuff that you will see if you go on to a statistics class. Alright, so the field of statistics can be defined as the science of collecting, organizing, and summarizing data in such a way that valid conclusions and meaningful predictions can be drawn from them. So the last part is very important. If you do a whole bunch of work but you can't draw a valid conclusion or predict something meaningful from that data, then it doesn't really help you at all. So, the first part of the definition, which was collecting, organizing, and summarizing data, applies to descriptive statistics. This is what you do in the first half of the statistics class here at CCGA. The second part of the definition says statistics is about drawing valid conclusions and making meaningful predictions. This describes inferential statistics, which is what you do in the last half of the statistics course here at CCGA. We're going to be looking at some descriptive statistics today and some very basic descriptive statistics. So we've already looked at the word relative frequency. So some of this will probably be review for you. Whenever you start a statistical study, the first phase is always the collection of data. And even before you collect the data, you have to decide how you're going to collect the data. So there's a bunch of different ways that you can collect data, a bunch of different ways that you can choose the people that you're going to collect the data from, or choose the cities or the animals or whatever you're collecting data on. There's lots of different ways to choose how you're going to select the individuals that are going to be in your study. So to summarize the data and detect any trends, we have to organize the data. And this is the second phase of descriptive statistics. And organizing data is very important. If you have a bunch of data but you don't know how to organize it, then once again, like I said before, it's not helpful to you. So one of the most common ways to organize raw data is to create a frequency distribution, which is a table that lists each data point along with the number of times it occurs, which is called its frequency. Alright, so frequency distribution is really simple. It's just a little table. The first column lists each data point. So if it's ages, they'll list each individual age. If it's countries, they may list each individual country. Just whatever you're collecting data on. And then the second column is the frequency column. This is the number of times that data point occurs in your data set. We've already talked about relative frequency. We said that relative frequency is found by dividing frequency divided by total. So it's frequency divided by total. Let's look at our first example. This is a word problem and it's kind of long, so I'm going to split this up into a few pages. It says, while bargaining for their new contract, the employees of To Die For Clothing asked their employers to provide daycare service as an employee benefit. Examining the personnel files of the company's 50 employees, the management recorded the number of children under 6 years of age that each employee was caring for. Alright, so let's just summarize what's going on here. There's a bunch of workers or employees and they are bargaining for a new contract. They want their employer to provide daycare services. And what the management is going to do to determine if this is something that they're interested in is they're going to go to each employee and they're going to ask them, how many children do you have that are under 6 years old? Now, think about why they would want to know how many children that they have that are under 6 years old. Why wouldn't they just ask, how many children do you have? Alright, so instead of asking how many children do you have, they're specifically asking how many children do you have that are under 6 years old, because those are the kids that are going to need the daycare services. All right, so that's the only thing they're interested in. They're interested in how many children are they going to be having to provide daycare services for. The following results were obtained from the employees. All right, so there should be, if you count them up, there should be 50 numbers here. Each number represents an employee, and the number is going to be how many children that they have, that specific employee has, that's under 6 years old. So you can see, if you're looking at this first person right here, this person has 0 children under the age of 6. All right, so whereas if you go a couple down right here, this person has 2 children under the age of 6. And if you look across the data, it looks like a lot of people don't have any kids that are under the age of 6, but you see several that have 1 or 2, and then only see 1 that has 5. So most people have around 1 to 2 kids, or 0 kids under the age of 6. All right, so let's organize the data by creating a frequency distribution. Organizing this data into a frequency distribution is going to make it so much easier to see how many people are going to need these services, how many employees will need the daycare services, and it also just helps it, like I said, get it organized, and makes it a lot easier to tell someone or convey your information to someone else. This is our frequency table. You can see that it has 3 columns. The first column is the data points. So we have 0 to 5 because that's how many kids the employees had. And then we have our frequency column and then our relative frequency column. I just threw in this relative frequency column just to practice because you're going to need to do this for some of the homework problems. Alright, so the next thing we need to do is fill out the table. So let's start by filling out the first row. So we need to count up how many people had 0 kids. Alright, so let's go through that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 people, 16 employees had 0 children under 6 years old. Right, so 16 goes in the frequency column for 0. Next, you're going to start counting up your ones. All right, so let's start counting up the ones. This is the way that I like to count up the data points for my frequency column. If you can just look at this and not have to cross them off, if you can just count them up in your head, there's no reason for you to X each one out. It just helps me to see what I've already counted and what I have left. All right, so let's count up the number of ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so 18 employees had 1 child under the age of 6. All right, so 18 goes in our second row. Now, if you want to pause the video and finish filling out your frequency column, and then you can make sure that it matches up with what I have, now would be a good time to do that. Let's count up the 2s. Once you count up the 2s, I think we can just eyeball it and see how many we have left. All right, so let's count up the 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so 9 people had 2 children under the age of 6. And from here, I could kind of just tell how many I had left. So it looks like I have 4 people that had 3 children under the age of 6. Now I'm counting up my 4s. There are 2 4s. So there's 2 people that have 4 children under the age of 6. And then 1 person has 5 children under the age of 6. All right, so that is your frequency distribution. Technically, you only need the first two columns for this to be called a frequency distribution. The relative frequency the relative frequency column is useful, in my opinion, because it's going to tell you what fraction of your employees fall into this category. So, for example, what fraction of the employees have 0 children under the age of 6? And it's also really easy to fill out, so it's going to take you hardly no time at all. So recall that relative frequency is just frequency divided by total. So you can leave this as a fraction. I'm fine with you leaving it as a fraction that's not simplified. That's totally fine with me. If you prefer, you can convert it into a decimal, so you just plug it into your calculator and then convert it to a decimal. It's totally your preference, just whatever you like doing. I'm going to leave them in fraction form. Alright, so the first thing we need to figure out, because we've got the frequency, that part is already filled out. Now we just need to know the total. Now if you remember from before, they told us that this was 50 employees, but if you want to double check, all you have to do is add yourself a little total column, or sorry, a little total row at the very bottom, and then add up all your frequencies. If you add up all these frequencies, they should add to 50. That's one way to check that you completed your frequency distribution correctly. So if you add up all the frequencies and they add to what you know the total should be, then you know you did it right. Now, for relative frequency, really simple. We're just going to take frequency divided by total. So for this first row, it's going to be 16 over 50. All right, so once again, let me just show you where I got that from. The frequency was 16. The total was 50. All right, so 16 over 50, frequency over total. Now, let's finish up. Like I said, if you want to pause the video, fill the rest of yours out, and then make sure yours match mine. I'm going to go through these kind of quickly. So for the number of children under 6, the people that have 1 child under the age of 6, the relative frequency is 18 over 50. I'm kind of staggering these so that they don't all run into each other. So if you're wondering why I scooted that one over some. Next, for 2 children under the age of 6, the relative frequency is 9 over 50. Once again, I should have mentioned this on the last two, but you do not need to worry about simplifying. So I'm fine with you leaving these fractions unsimplified. And most of the time in your statistics class, this will be the case as well. You usually don't have to simplify fractions. Alright, for 3 children under the age of 6, we have a relative frequency of 4 over 50. The next row is 2 over 50, and then 1 over 50. And then, once again, like I said, one way that you can check your answer for the relative frequency, if you add up all of these fractions, they should add to 1. Alright, so all of those fractions added together should add to 1. So that's how you can check your answer there. Alright, now we need to talk about grouped data. Now, what is grouped data? This is where you have raw data consisting of many non-repeated data points. And when you have a data set like that, it's not always the best to list each one separately, because that's not going to help us to see any trends that the data might contain. So for example, if you looked at the ages of the students in my class, instead of listing out 18, 19, 20, 21, you may want to group them up like 18 to 20, 20 to 22, 22 to 24, and then you could see more trends that way. So if you have a data set like this where you have many non-repeated data points, it's useful to group the data into intervals or classes and then determine the frequency and the relative frequency of each group or class or interval rather than each data point. Alright, so here we have an example with ages. This is the perfect example where you have a lot of data points and you don't have a lot of repeats. Alright, so you don't see a lot of the same number repeated. So it says Keith Reed is he's an instructor for an acting class offered through a local arts academy. The class is open to anyone who is at least 16 years old. 42 people are enrolled, and their ages are as follows. All right, so we already know that our total is going to be 42. When we go to do our relative frequency row, or column, excuse me, we know that the total is going to be 42. All right, so here's our data. Let's see. I like to go through whenever I'm looking at a data set, and I like to see what the youngest or the smallest number is and what the largest number is. So the smallest number here is 16. The largest number, let's see. Do you guys see it? I think it's 62. All right, so let's make a relative frequency. Okay, so it says organize the data by creating a frequency distribution. So here we have our frequency distribution. Notice that they've already taken the ages and divided them up into groups for you. Sometimes these are called groups, sometimes they're called intervals, and sometimes they're called classes. So if you hear any of those three words, classes, intervals, or groups, just know that those three mean the same thing. Alright, so we're going to start by counting up the number of people who are in the first age group, which if you read this using the mathematical notation, it says 16 is less than or equal to x, which is less than 24. X represents the age. So people that are between 16 and less than 24. All right, so 16 to less than 24. So less than 24, that means the same thing as 23 or less. All right, so we're going to count up the number of people who are less than 24 years old. All right, so let's go through and count those up. The first one I see is in the second column of numbers here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so 11 people are 16 to less than 24. All right, now we're going to count up our second age group, or the number of people that are in our second age group, which is 24 to less than 32. All right, so let's look at the ones that are left that are less than 32 years old. All right, less than 32. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so 13 people are less than 32 years old, or really technically we should say they're 24 to less than 32 years old. All right, now our third age group, we're doing 32 to less than 40. All right, so look at the ones that you have left that are less than 40 years old. So 1, 2, 3, 4, 5, 6, 7. All right, so 7 people were in the age group 32 to less than 40. All right, our next age group is 40 to less than 48. So you're counting up the number of people who are less than 48 years old. All right, so let's see. We're starting over here in the fifth column with 45. So 1, 2, 3. All right, so kind of a small group there. 3 people were 40 to less than 48. Now let's count up the number of people who are 48 to less than 56. All right, so 48 to less than 56. So we have 1, 2, and that's it. Yep, so only 2 folks in that group. All right, and then our last age group, 56 to less than 64, we have 6 people left over. So I didn't mark those out because you can just count those up. 1, 2, 3, 4, 5, 6. All right, so 6 people in that last age group. Now we're going to go through and fill out our relative frequency column. If you recall from before, our total was 42. You can confirm this just by adding up the numbers that you have here. So let's go ahead and fill out our relative frequency column. Remember, that's frequency over total. So our first our first row is going to be 11 over 42, 13 over 42, 7 over 42, 3 over 42, 2 over 42, and 6 over 42. And like I said before, one way that you can check your answer for the relative frequency is that entire column should add to 1. Here I have included a screenshot of a table from your textbook about how to construct a frequency distribution. So if you're still struggling with this, even after the 2 examples that we went through, then I wanted to have this table in here for you so that you could write the steps down. And that way you have, defined steps for constructing a frequency distribution. I think probably most of you are going to pick up on this really quickly, but just in case, here are the steps for you. You don't need to have these memorized. Just know how to construct a frequency distribution. You don't need to have this word for word memorized. The next topic we need to cover is histograms. A histogram is a diagram that shows how the data in a data set are distributed within each interval or each class or each group. And we can also use them for the data set like we had for the number of children that were under age 6. So it doesn't necessarily have to be an interval, but this is just the way that your textbook words this definition. These are the steps for constructing a histogram. The first step is to mark off the class limits on a horizontal axis. Place your frequencies on the vertical axis, and then we draw a rectangle above each interval. And the height of the rectangle is going to correspond to the frequency. So I don't think you need to write these steps down. I think once you see me do this histogram, I think you'll pick up on it really quickly. But if you need to, you can always come back to this point in the video and write down these steps. So let's go through our first example where we're going to draw a histogram. It says, draw a histogram depicting the distribution of the ages of the people in Keith Reed's acting class. So that was from our last example. I'm going to go ahead and pull up the frequency distribution. It's important that you have this close by when you're drawing the histogram because this is what you're going to use to determine the heights of the bars on your histogram. Alright, so we're really only going to be using these first 2 columns here. Alright, so you only need to look at those first 2 columns. The first thing that I'm going to do when I start my histogram is I like to go ahead and draw my horizontal and vertical axes. I usually draw the horizontal a little bit longer than the vertical. Alright, so the ages are going to go on the horizontal axis and the frequency is going to go on the vertical axis. We're going to go back at the very end and label these. You could label them before you start if you want to. I just happen to do them at the end. Alright, so the first thing you're going to do is go ahead and mark off where your bars are going to go. So I'm just going to use the numbers from this first column here. So I'm going to go 16 to 24, and then 24 to 32, 32 to 40, 40 to 48, 48 to 56, and then 56 to 64. You want to try and make these all about the same width, but if it's not perfect, that's okay. It doesn't have to be. Now, for the vertical axis, this is where your frequencies are going to go. It's important that you look at the numbers that you have and then draw your little tick marks on your vertical axis. So our smallest frequency is 2. Alright, so our smallest frequency is 2 right here. And our largest frequency is 13. I decided to count it by 2s. You could count it by 1s if you wanted to. If you do count it by 2s or 5s or 10s or whatever, it's important that you label your tick marks. That way the person that's looking at this knows that you counted up by something other than 1s. Alright, so I'm counting up by 2s, so I'm labeling them 2, 4, 6, 8, 10, 12, 14. I'm only going up to 14 because my highest frequency is 13. Now I'm going to draw the actual bars of my histogram, and the bars are going to all touch each other. Alright, that's very important. So the bars are all going to be touching each other, and I'm going to determine the height of the bar by looking at the frequency. Alright, so we're starting with our 16 to 24 age group, and the height there was 11, or the frequency is 11. So that tells us how tall our bar should be. So notice that I have the height of that bar at 11. So halfway between 10 and 12. My next age group, 24 to 32, the frequency is 13. So that's how high I need to draw my next bar. Then we have 32 to 40, the frequency is 7. And then 40 to 48, the frequency is 3. 48 to 56, the frequency is 2. And then 56 to 64, the frequency is 6. Some people like to draw the actual frequency above the bar. If you want to do that, you can. So what I'm saying here is some people will draw like a little 6 above this bar, so that when you look at it, you immediately know what the height is. But you don't have to do that. That's just your preference. Now, the purpose of a histogram, it makes it really easy for people to see trends in your data. So I can easily see from this histogram that it looks like most of the people in the acting class are younger than 32. All right, so that's a popular age group. Maybe not necessarily most of the people. Let's see, it looks like 10 and 8. Yeah, actually there are, most of the people are less than 32. So how I figured that out was I just counted up how many people were in this big group, and then how many people were in this group here. Alright, so anyway, a histogram easily displays to the people who are looking at your data, it easily displays what the trends are in your data set, and also helps them to see what are the high points and the low points. Alright, so now I just need to go in and add my labels. I'm labeling my horizontal axis as age and years, my vertical axis is frequency, and then I'm going to give this a title, and I'm just calling it Ages of Acting Students. You can call it whatever you want, as long as it is a good description of your data set. Now, the histogram that we just constructed was using intervals of group data. So for instance, it says the first group of ages in Keith Reed's acting class was from 16 to 24 years old. However, if you have a data set like we did in example 1, where we had the number of children under age 6, so if you have single valued classes, that's okay too. So let me show you how we would construct a histogram whenever we have single valued classes of data. A sample of high school seniors was asked, how many television sets are in your house? The frequency distribution below summarizes the data. Construct a histogram using single valued classes of data. Right, so they're giving us the frequency distribution, and all we have to do is construct or draw the histogram. Alright, so here we're about to draw our histogram. I have my frequency distribution right here, so I can see what the height of my bars needs to be. I'm going to go ahead and draw the vertical and horizontal axes, and now I'm going to label my horizontal axis. I went ahead and gave this a title. I just called this High School Students and TVs. Like I said, you can title it whatever you want. This is just what I came up with. My horizontal axis is the number of television sets, and once again my vertical axis is frequency. Now I'm labeling my my intervals down on my horizontal axis. So my first interval is 0, and then 1, 2, 3, 4, and 5. So again, that's just based on that first column of information right here. So that came from there. Now my frequency, once again, I need to check and see what my numbers look like, and then I'll decide how I want to count. So my lowest frequency is 1, my highest is 18. I went ahead and counted again by 2s, but like I said, if you want to count by 1s, that's fine too. I wouldn't count by fives probably, just because there are some weird numbers in here like 13 and 18. So it may be hard to tell if you count by fives what the actual value is. So let's see, our first bar for people that have 0 TV sets in their house, the frequency is 2. I need to go ahead and label my tick marks before I start drawing my bars, so let me do that. All right, so I went 2 to 18, counted by 2s. So my first bar has a height of 2. My next bar for 1 television set, that's 13. My next bar for 2 television sets is 18. And then for 3 TV sets, it's 11. And then 4 TV sets, it's 5. And then 5 TV sets was 1. All right, so you can see the highest group, or the most popular number of television sets was 2 for these kids. And the least popular number of TV sets was 5. Or the least common, I could say. All right. One thing that I want to make really clear to you, because you are going to see this again when you get to your statistics class, is I want to make sure you understand the difference between a histogram and a bar chart. On the left is your histogram, and on the right is your bar chart. So what do you notice is different about these two diagrams? The first thing that I notice is that the bars on the right hand side in that bar chart, the bars aren't touching. And in my histogram, the bars are touching. Alright, so that is the main difference, or that's the difference that you probably notice first between a histogram and a bar chart. On the left we have a histogram. Notice how the bars touch. Histograms are used for quantitative data. Quantitative means numbers. Alright, so your horizontal axis needs to be some kind of numeric value if you're dealing with histograms, or if you're constructing a histogram. Now for bar charts, look at our horizontal axis there. Bar charts, the noticeable difference here is that the bars do not touch, and bar charts are used for categorical data, which is where the horizontal axis is separated into categories. So here the categories are countries. So again, histograms, the bars touch, and they're used for quantitative or numerical data. Bar charts, the bars do not touch, and they're used for categorical data, which is where your data are in categories. Another word for categorical data is qualitative data. I want to go through one homework problem with you where you're looking at how to construct a pie chart. It says the following table lists the top 5 reasons given by patients for emergency room visits in a certain year. Construct a pie chart to represent the data. All right, so here are the top 5 reasons: stomach pain, chest pain, fever, headache, and shortness of breath. And these are the number of patients in millions that visited the emergency room for that reason. All right, so constructing a pie chart, this is nothing that we haven't already done. Everything that you need to know to construct a pie chart, you've already learned. So all you're going to need to do is add in a column for relative frequency. All right, so relative frequency, again, that's frequency over total. So let's figure out what the total is. The total here, if you add up 7.2 plus 5.6 plus 5.3 plus 3 plus 2.9, the total is 24, so that's 24 million in total. So the relative frequency of stomach pain is 7.2 over 24. For chest pain, it's 5.6 over 24. Fever is 5.3 over 24, excuse me. For headache, it's 3.0 over 24, or just 3 over 24. Shortness of breath is 2.9 over 24. Now you have to do a couple of more steps when you are constructing a pie chart. The first thing we need to do is we need to figure out what is the decimal form of all these fractions. So just type these in your calculator and get the decimal form. 7.2 over 24 is 0.3. 5.6 over 24 is 0.233 repeating. So the little line over the 3 tells you that it continues on repeating. 5.3 over 24 is 0.2208. 3.0 over 24 is 0.125. And 2.9 over 24 is 0.1208. Now the last thing you're going to have to do before you construct your pie chart is you have to take these decimals and turn them or convert them into percentages. Now we learned how to do this a couple of sections back, so hopefully you remember how to do this. Remember, if you're taking a decimal and converting it into a percentage, you take the decimal and you move it to the right 2 places. So 0.30 becomes 30%. 0.233 becomes approximately 23%. So I'm just rounding to the nearest whole number. So 23.3 is approximately 23%. Alright, the next one is approximately 22%. Then we have 0.125, that would be 12.5%, which is approximately 13%. And then 0.1208, that's 12.08%, which is approximately 12. Now, let's look at our choices. Here are our 5 options for pie charts. I'm going to pull back up our relative frequency distribution here, and you're just going to match up the percentages with the pictures. Stomach pain was 30%. So there's actually only one option where stomach pain is 30%. So really you only needed to fill out that first row to figure out what the answer was. So if you look at your pie chart, the top left it's stomach pain 13%, top right stomach pain 30%, bottom left stomach pain 12%, and then bottom right stomach pain 12%. So it must be that top right option. Alright, if you have any questions or if you would like to see another pie chart example, just send me an email, or you can post in the Copy Shop Q&A section on our D2L page.